In the last video, we learned about how to find the correlation coefficient, which measures the linear relationship between the two variables, okay? And we used calculator how to find out the correlation coefficient of a sample. We denote it by R. Now, what we want to do is, by using the data from the sample, or by using the correlation coefficient from the sample, we want to test the hypothesis about the relationship between two variables in the population, okay? So what we check is, okay, so from the sample we got the correlation coefficient this much. So can we apply that thing in the population? For example, let's say, suppose you got the sample correlation coefficient is 0.7, positive 0.7, okay? That means there is a strong linear relationship between, strong positive linear relationship between X and Y. But can we apply that in the population? Meaning that, is that true in the population? Is that X and Y have positive, strong positive correlation in the population or not? So that's what we are going to test next, okay? That is the hypothesis testing to test the relationship in the population. So what are the steps? Step number 1 is write the null and alternative hypothesis. Again, rho is the population correlation coefficient, right? Population correlation coefficient. Okay, so rho equals to 0 is H sub 0. That is the null hypothesis is there is no linear relationship. And the alternative hypothesis is there is linear relationship. Okay, so we want to test those. Now, to do that, what we do is we need to find the critical values. To find out the critical value, what we do is we use the table I. So table I is given in the next page. So this is table I, okay? So, and we always use the degrees of freedom n minus 2. To use the table I, we need the degrees of freedom n minus 2. So n is the number of pairs and you subtract 2 because there are two data sets, right? One is X and the other is Y. So n minus 2 degrees of freedom. Step number 3 is find the correlation coefficient R. So we use calculator to find out the correlation coefficient R. And then in step number 4, we make a decision, that is, if R is greater than the positive value of the critical value or less than the negative value of the critical value, then we reject the null hypothesis. And number 5 is summarize the result. Okay, let us do one example and then things will be clear, okay? So a random sample of scoring leaders from NHL showed the following numbers of assists and total points. Okay, based on this data and alpha equals to 0.05, can it be concluded that there is a significant relationship between the two? So number of assists is X and number of total points I denote by Y, because the total points depend on assists too, right? Number of assists. Okay, so what is the step number 1 is write down H0 is always rho equals to 0. That means there is no relationship between the X and Y in the population. And H1 we denote by, we write rho not equals to 0, meaning there is some linear relationship. Okay, now step number 2 is find the critical value. Okay, so critical value, we use table I. Okay, so what is alpha? Alpha is 0.05. What is the degrees of freedom? Degrees of freedom is n minus 2, right? So that is n is 1, 2, 3, 4, 5, 6, 7 pairs. 7 minus 2, that is 5. So the degrees of freedom is 5. Alpha is 0.05. So let us go to the table I. Degrees of freedom is 5 and alpha is 0.05. That's what we got, right? That is the critical value. So we write plus and minus for that. So 0.754. So the critical value is plus minus 0.754. Okay. So the next thing we do is we find out the R, correlation coefficient R. We use calculator to do that. Let us enter this value in your calculator. Okay. So let us enter those values. So let me clear what I have here. And then go to the stat and then edit, hit enter. Let me enter the first thing. So 26 X is entered in L1, okay, and then 29, 32 and 34 and 36 and 37 and then 40. Okay, and then delete the 45. We don't need that. Okay, now we're done. So let me enter the y values. By the way, let me enter the y values in the L2. Okay, I mean you can clear that L2 first and then enter, or you can override it. Okay, so let me do that. Let me clear what I have in L2, and I want to enter the numbers there. So 48. Okay, what does that mean? That means if there were 26 assists, then the total number of points were at that time 48, and 29 assists has total points 68, and so on, right? 48, 68, hit enter. 66, hit enter. 69, hit enter. 76, hit enter. 67, hit enter. And then 84, right? 84. Okay, hit enter. And if there is extra, we will remove that, so there is no extra. Okay, now what we do, go to the stat and then calc. Okay, number 4, right? So y equals to x plus b. So x is entered in L1, y is entered in L2. There is no frequency, there is no we don't do anything for restore regression equation. And then what we do is r equals to 0.8611. That's what I got. So r equals to 0.8611, 0.8611. Now what does it say is the critical value is negative 0.754, negative 0.754, and positive 0.754, right? These are the critical values. Actually, we use the t-test for this, but see this, if you use table I, then it is even shorter. You don't have to even use the t-test here. What you do is, if your R value, if your correlation coefficient value, sample correlation coefficient value fall in the shaded region, meaning greater than that positive critical value and less than negative of the critical value, although the table give you positive, we take both positive and negative, okay, to draw that. If this R falls in the shaded region, you reject the null hypothesis. Otherwise, you do not reject the null hypothesis. Okay, what is R? R is 0.86. 0.86 is bigger than 0.754, okay? So what you do is, this is the R value. So it falls in the shaded region. So we reject the null hypothesis. That's what we do, okay? So what we get is, since R is greater than the critical value, positive critical value, we reject 80. That means hence there are enough evidence to support the claim, right? To support the claim, because the claim is the alternative hypothesis. To support the claim that, so because if it was stated as null hypothesis is the claim, then that will be the claim. The H0 will be claim. Otherwise, H1 will be the claim. Okay, so it doesn't say anything. That means H1 is the claim. Claim that there is a linear relation between assist and total points. Okay, that's how you write the conclusion. Let us do another example that is related to the COVID. Okay, let us see that. So I took this data from the worldmeter.com. Okay, the population in millions and the number of COVID related deaths per million population for 7 countries with most COVID cases is given below. For alpha equals 0.05, test if there is a linear relationship between the variables. So this is the given data. Okay, so you can say so this is x and this is y. Okay, so we want to test whether there is a linear relationship between x and y or not. Okay, so what we do first is write down H0 and H1. So H0 is rho equals to 0. It is always the same. H0 and H1 is always the same in case of the correlation coefficient is, and then H1 is always rho not equals to 0. It is like a two-tail, right? Rho is the, what does it say is, there is no linear relationship between the population and the number of deaths by the COVID. Okay, and it says there is a linear relationship between the population of the country and number of deaths, COVID related deaths of that country. Okay, so let us find out the critical value. Critical value is alpha is given as 0.05, and what is the degrees of freedom? Because how many pairs are there? 1, 2, 3, 4, 5, 6, 7 pairs. So 7 minus 2. be careful. One of the things that is different from the hypothesis testing in chapter 8 is here we take the degrees of freedom is n minus 2. There we took degrees of freedom is n minus 1. So that is 5 degrees of freedom and alpha is 0.05. Let us go to the table I and then see alpha is 0.05 and 5 degrees of freedom is all again the same value, right? 0.754. We take plus and minus here. So the critical value is plus minus. So the critical value is 0. So plus and minus 0.754, right? Now we need to find out the correlation coefficient. How do we find the correlation coefficient? We use calculator. So you enter these and you enter those values. Okay, let us do that. Let me clear what I have there. Okay, on L1 I have all those values. I want to clear that, and I want to clear L2 as well. So let us clear that L2 values and then we will enter the new values. Okay guys, so 331.6 is the first, and 1384.6 is the population of the India. Brazil is 213.1 to 113.1, and then Russia is 146 million, 146, and then 65.3 is the other one. 65.3, 46.8, 46.8 is the another one, and 45.3 is the other one. So these are the population of those countries, and then total number of deaths related to the COVID is 713, 89, 751. These are per million population, okay, and 195. Hit enter. 567, hit enter. 767, hit enter. And 687, hit enter. Okay, so these are the number of the population in million and number of deaths per million population. Okay, now what we want to do is we want to record R. So go to the stat and then calc and then go to number 4. So if you do that, you will get R equals to negative 0.67. That's what I got. So negative 0.67. I want to take 4 decimal places. Okay, 0.6798. So 98. It is in the sample. At least from the sample you can see that. But do we reject or do not reject the null hypothesis? Let us see that. So this is, so what are the critical values? The critical value is negative 0.754 and positive 0.754. So what is R? R is 0.6798. 0.67 falls where? 0.67 falls here, right? Because greater than 0.67 falls there, because greater than 0.75 and less than negative 0.75 fall in the shaded region, meaning we do not reject the null hypothesis. Oh, I see. So we do not reject the null hypothesis. So let us write down the conclusion. So since R does not fall in the critical region, we do not reject H0. We do not reject means there is no relationship between the population and the number of deaths. Okay, hence we can conclude that there is no linear relation between the population and number of COVID related deaths. So what we can conclude from this sample, okay, so if you pick a bigger sample, meaning that if you pick many countries, then it may be depending on the population. Okay, the number of COVID deaths may be depending on the population. But from this sample that we picked, okay, from this sample of 7 countries, we can say that the population, the number of COVID related death does not depend on the population. Meaning, the bigger highly populated country does not have a higher number of deaths and so on. Okay, so there is no linear relationship. That's what we can conclude from this sample. Okay guys, thank you.